Welcome, scholars. We are so glad that you have joined us today. During this show, we are going to support you in navigating word problems through reasoning to help you continue to be the wonderful mathematicians that we know you are. From number sense to algebra, we've got it all covered. So let's get started.
4, 3, 2, 1.
Hey guys, welcome back to Count on Us, Reasoning and Problem Solving Grade 3. I'm Coach Young, coming to you with another engaging math mini lesson. We are back for another week on air supporting 3rd through 5th grade math learning on Monday afternoons and 6th through 8th grade math learning on Wednesday afternoons. Both shows will air from 5 o'clock to 5:30 p.m., so make sure you always tune in. Our show will focus on specific grade level standards and problem-solving strategies to develop you into successful mathematicians. So let's get started. At the end of today's mini lesson, you will be able to say, I can use multiplication and division within 100 to solve word problems. Solving today's reasoning and problem-solving problem will be as easy as 1, 2, 3. Here are the steps we will follow as we solve today's problem. Step 1, read and understand the problem. Step 2, ask yourself, what do you know that will help you to solve the problem? And step 3, solve the problem by doing the math. For the first read, I will read the problem to you. Then we will discuss what the problem is about. Mr. Haley bought a total of 36 pictures. The pictures are only sold in packages. Each package came with 4 small pictures, 3 medium pictures, and 2 large pictures. How many pictures were in each package? Show your work. How many packages did he buy? Show your work. So let's think about what this problem is about. After reading this problem, I imagine Mr. Haley buying a total of 36 pictures. I'm visualizing boxes since the pictures are only sold in packages. And each box has 4 small pictures, 3 medium pictures, and 2 large pictures. For the second read, I would like for you to read the problem along with me. Mr. Haley bought a total of 36 pictures. The pictures are only sold in packages. Each package came with 4 small pictures, 3 medium pictures, and 2 large pictures. How many pictures were in each package? Show your work. How many packages did he buy? Show your work. Now I want to think about what the quantities and units are in the problem. Remember that quantities are the numbers and units are what's being counted. So in this problem, we see the quantity of 36 representing the total number of pictures. The quantity of 4 represents the small pictures. The quantity of 3 represents the medium pictures. And the quantity 2 represents the large pictures. For the third read the problem to yourself one more time. Think about what's missing from this problem. It is important that you understand what the problem is about, as well as understand the quantities and the units in the problem before rushing to answering the question. Now that we have done that, what questions can we ask ourselves about the problem? Here are a couple of questions I came up with. How many pictures are in each package? And how many packages did Mr. Haley buy? This is a visual of the entire problem. This is the way your problem will look like virtually. You will be given a space to explain your work, and you will also be able to enter equations in the space using the equation editor located on the right side of your workspace. You may also see a drawing box for you to model your work using the drawing tool. The questions we will be finding the answers for are: how many pictures were in each package? And how many packages did he buy? Now, what do we know that is going to help us solve this problem? We know that Mr. Haley bought a total of 36 pictures. And we know that the pictures are only sold in packages of 4 small pictures, 3 medium pictures, and 2 large pictures. Let's figure out how many pictures were in each package. We know that 4 represents the small pictures in the package. 3 represents the medium pictures in the package. And 2 represents the large pictures in the package. When I do the math and add all of the pictures together, I get a total of 9 pictures in each package. So how many packages did Mr. Haley buy? We know that there are 9 pictures in each package, and we also know that Mr. Haley bought a total of 36 pictures. As you solve this problem, it is important to label your work. Here we have 9 pictures represented for each package: the 4 small pictures, the 3 medium pictures, and the 2 large pictures. We kept creating packages until we reached our total of 36 pictures in all. Once we reached that total, we see that Mr. Haley bought 4 packages. Written as a division equation, we have 36, the total number of pictures Mr. Haley bought, divided by 9, the number of pictures in each package, which gives us a quotient of 4, the number of packages Mr. Haley bought. This can also be written as a multiplication equation. An unknown number times 9 equals 36. And for this problem, we know that the unknown number represents 4, the number of packages Mr. Haley bought. As you are working on your math problem online, remember that your screen will give you a work area where you can type in your response, including equations using the equation editor. You may also see a drawing box to model your work in the space provided. Make sure to use that area to show all of the work you did to solve the problem, and don't forget to label. This allows anybody looking at your work to clearly see your understanding of the problem. Today, we read the problem for understanding, used what we knew, and solved a word problem that included multiple operations. What strategies did we use? We applied the 3-read strategy, we visualized the problem, and we drew a model to solve for our problem. Now you can say that you can use multiplication and division within 100 to solve word problems. That's it for today, 3rd grade students. The next segment will be for our 4th grade students. See you next time.
Welcome back to another 4th grade edition of a mini lesson for Count on Us. I'm Coach Brenner. Today we are going to be looking at some real world problems, just like how we've tried to bring over the last couple weeks. Today it's talking about different arrangements in terms of seating, how many seats we can create. And we're kind of looking at the perimeter. Okay, so we're going to have some tables. They might be rearranged different ways. We're going to see how many people can sit at certain tables. So get your thinking cap on. And teachers do this all the time when they're rearranging their desks, making sure that there's enough seats for all the students, especially maybe in your science classroom where you have those big science tables. Teachers want to make sure that there's enough seats for students, but sometimes they rearrange their desks a little differently. All right, so today, put those thinking caps on. We're going to see how many different people can sit at these tables, if they're just pushed together, if they're rearranged in different orders, so that we can see if there's enough seats and spots for students to sit. So make sure you have your pencil and paper, your thinking caps on, and ready to turn those math brains on. Let's get started on the problem. In today's lesson, fourth graders are going to be able to extend patterns in seating arrangements around tables. They're also going to be able to generate a number or shape pattern that follows a given rule. So we got to put on our thinking caps right now because we're about to dive right into this problem. All right, so first, here's the problem. Restaurants often use small tables to seat customers. One chair is placed on each side of the table so that 4 chairs fit around the table like this. So here's our table, and we have 1 person, 2 people, 3 people, 4 people. So here's where the 4 chairs are and the 4 people can sit. If it's 4 people at the table. All right, so keep this in mind, how the seating arrangements are for the chairs on the outside of the table. Now, but we also need to know, sometimes more people come and the waiters have to rearrange the table to fit more people. All right, so if we look here, so when groups with more than 4 people come into the restaurant, the waiters must push the smaller tables together to make a larger one. For example, 2 tables pushed together like this. Now, where do you think the chairs would go? Here's a chair, another chair, 3rd chair, 4th, 5th, and 6th. So how many chairs for 2 tables? 2 tables seats 6 people. All right, so keep this in mind as we're moving forward. Notice we are sitting on the outside of the tables. Once they're combined together, this area, let me pull my pen, this area cannot hold a seat. All right, so keep that in mind as we are pushing these tables together. All right, now, how would it look if we put 3 tables together? How many chairs would we need? Now let's start thinking about the possible rule for these tables. We know that 1 table sat 4 people, 2 tables sat 6 people. So if we have 3 tables, what might be the rule here? Well, we have 1 chair, 2, 3, 4, 5, 6, 7, 8. So here we know we need 8 chairs. So let's think about that rule. 1 table is 4 chairs. 2 tables is 6 chairs. 3 tables is 8 chairs. So what would be that rule? Let's keep thinking about that because we know the chairs are going up. So I want you to think about that at home. All right, now, how would it look if we put 4 tables together? How many chairs would we need? Let's start filling out this picture. 1 chair, 2 chairs, 3 chairs, 4 chairs, 5 chairs, 6 chairs, 7 chairs, 8 chairs, 9 chairs, 10 chairs. So here we would need 10 chairs. Now, what's something that we can use to keep track of all of our data here? If somebody said a table, you're correct. So what we already have is we know that 1 table equals 4 chairs, 2 tables equals 6 chairs, 3 tables equals 8 chairs, 4 tables equals 10 chairs. So if we're thinking about this rule, notice as we're adding a table, how many chairs are we adding? If you said that we're adding 2 more chairs, you'd be correct. So our rule is each table, we're adding 2 more chairs. So if we have 5 tables, 12 chairs, 6 tables, 14 chairs, 7 tables, 16 chairs, 8 tables, 18 chairs, 9 tables, 20 chairs, 10 tables, 22 chairs. So when we look at this table, we notice that the pattern is that we are adding 2 chairs for each table. Now, what if I change the setup for the 3 tables? Would the number of chairs change or stay the same? Who thinks they might change? Who thinks they're going to stay the same? Well, let's figure it out. All right, so if you look here, we don't have them just straight across in a row. We have 2 up top and then 1 underneath. Maybe this is how the restaurant had to try to fit these tables in. So we know that we still have to fit the chairs around the outside. So we have 1 chair, 2 chairs, 3 chairs, 4 chairs, 5 chairs, 6 chairs, 7 chairs, 8 chairs. So did the number of chairs change? Nope. We would still need 8 chairs. All right, let's look at one more. Now, would the number of chairs change if we rearrange 4 tables together? So let's remember, 1 table was 4 chairs, 2 tables was 6 chairs, 3 tables was 8 chairs, and 4 tables were 10 chairs. So let's see if we have 10 chairs here or if it changed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nope, we would still need 10 chairs. So doesn't matter which way we rearrange these tables, we would always have the same amount of chairs. Thanks for tuning in to another 4th grade edition of our Count on Us mini lessons. Like I said, we're really trying to pull in these real world problems where you can see how the math that we're doing can be used in everyday life. Restaurants, if you're a restaurant worker, if you're setting up these tables, if you have a big party, if you're a wedding planner, if you're having a birthday party, the activity that we did today is something you'd have to do to make sure that you have enough chairs, enough tables set up for all of your guests. So this is where math really comes into play. It's kind of like a puzzle as well. So you guys at home that like to solve puzzles, it's just something that you can see and kind of can move around to see if it's going to work. Especially those last 2 examples where we moved the tables. They weren't just in a straight rectangle, but we kind of made them into different shapes. You could see that if the tables were touching, that way we needed to have the same amount of chairs. Now, if we had extended the problem and we had moved one of the tables without touching it from one or the other, we know that we would have opened up 2 more seats. We would have the one at the end of one and the one at the end of the other. So that's where you could have just played around in those extension type problems within your classroom. You could try those out just to see if the number of seats changed depending on how the tables were set up, if they weren't all touching each other's corners or sides or edges. All right, so today's lesson, hopefully you guys had some fun. I'm signing off, Coach Brenner, and remember, you can always count on us. See you guys next time.
I'm Coach D, and I'm excited that you're here with us today. I hope everyone is having an amazing day. Let's get started. Today, reasoning and problem solving will be as easy as 1, 2, 3. Here's our steps. 1, we're going to read the problem for understanding. 2, we're going to ask, what do you know that will help you solve the problem? And 3, we're going to solve the problem doing the math. One, read the problem. First, I will read the problem to you. Then we will discuss what the problem is about. This table shows the 3 different ways that toy animals are packaged at a factory. Package type, amount in the package. Bag, 36 toy animals. Box, 48 bags. Crate, 18 boxes. What is the problem about? I imagine in my head when I read this problem, a huge factory that's filled with toy animals. Some are in bags. Some are packed in boxes. And some packed in crates. Now this time, we're going to read the problem together. Let's go. This table shows the 3 different ways that toy animals are packaged at a factory. Package type, amount in the package. Bag, 36 toy animals. Box, 48 bags. Crate, 18 boxes. What are the quantities and units in this problem? Quantities are the numbers, and the units are what's being counted. For example, I have 3 brothers. 3 is the quantity, and brothers are the units. So what are the quantities and units in this problem? There's 36 toy animals in a bag. There's 48 bags in a box. And there's 18 boxes in a crate. For this third read, you're going to read this problem to yourself. What's missing from the problem? The question is missing. It's very important that you understand first what the problem is about, and second, understand the quantities and the units in the problem before you rush and try to answer the question. So what questions could we ask from this problem? How many toys are in the boxes? How many toys are in a crate? How many toys are in the factory? All questions we can ask from this problem. For this problem, we're going to be answering 2 questions. Part A, what is the total number of toy animals in 1 crate? Part B, 1 bag of toy animals weighs 12 ounces. What is the total weight in ounces of the bags of toy animals in 1 crate? Let's start by focusing on part A. What do we know? We know the problem is asking, what is the total number of toy animals in 1 crate? We also know there are 48 bags in 1 box. There are 18 boxes in 1 crate. So what is in 1 crate? 18 boxes. So before we can figure out how many toy animals are in 1 crate, we need to know how many toy animals are in 1 box. Here's the box. We know that there are 48 bags in 1 box, with the same number of toys in each bag. Now we could add all of those toys up, but we also have to remember that multiplication is a faster way to add equal groups. we know that there are 36 toys in one bag. And we know that there's 48 bags in one box. So each one of the bags have 36 toy animals. So that means we have 36 48 times. Our equation will be 48 times 36. Before we solve, let's make an estimate. 48 is close to 50 and 36 is close to 40. So I'm going to use the equation 50 times 40, which equals 2,000. So my answer should be close to 2,000. Let's use the area model to solve. 48 can be decomposed into 40 plus 8 times 36, which can be decomposed into 30 plus 6. Let's set up our area model. Our first area is 40 times 30, which equals 1,200. 8 times 30, which equals 240. 40 times 6, which equals 240. And 8 times 6, which equals 48. Now that we have all of our partial products, let's see what our answer is going to be. We're going to take the partial products and add them together. 0 plus 8 is 8. 4 plus 4 plus 4 gives us 12. 2 plus 2 plus 2 is 6. Plus the 1 is 7. And 1 plus 0 is 1. So there are 1,728 toy animals in one box. Have we solved the problem for part A? No. We still need to figure out how many toy animals are in one crate. There are 1,728 toys in one box. So that means each one of these boxes have 1,728 toy animals. So we can use the multiplication equation, 18 times 1,728. Now that we know our equation, let's start with an estimate. 1,728 is close to 2,000, and 18 is close to 20. So using the equation 2,000 times 20, which equals 40,000, that's going to be our estimate for this problem. This time, I'm going to decompose 18 so I can multiply by 10 and then use partial products to solve. So now I have 1,728 times 10 plus 1,728 times 8 because I decomposed 18 into 10 and 8. And the reason I did that was because I know that 1,728 times 10 is 17,280 because the digits increase by one place value when you multiply by 10. So now what I have to multiply is 1,728 times 8. And I'm going to use partial products. I'm going to multiply each place value times 8. So I have 1,000 times 8, which equals 8,000. 700 times 8, which is 5,600. 20 times 8, which is 160. And 8 times 8, which is 64. I'm going to take all of those partial products and add them together to get 13,824. Now that I have my problem, 17,280 plus 13,824,
That gives me 31,104. So there are 31,104 toy animals in one crate. So that answers our question for part A. Part B says, one bag of toy animal weighs 12 ounces. What is the total weight in ounces of the bags of toy animals in one crate? What do we know? We know the problem is asking us for the weight in ounces of the bags of toy animals in one crate. We know there are 48 bags in one box. There are 18 boxes in one crate. And each bag of toy animals weighs 12 ounces. In part B, we're looking for the total weight in ounces of the bags in one crate. In one crate, there are 18 boxes with 48 bags in each one of them. First, we must figure out how many bags we have altogether. Once we know that, then we can figure out how much the bags in one crate weigh. It's your turn now to do part B. Come back next week to see if we came up with the same answer. Let's review. Today 1, we read the problem for understanding. 2, we used what we knew to solve part A. And 3, we did the math. We used pictures to help us visualize the problem. We used the area model, partial products, and multiplying by 10. Now, you can use what you've learned today to help you with part B.
Welcome back to another Count on Us with Partnering with Parents. I'm Coach Brenner, and today what we're going to do is we're going to talk about some things you can do at home to make sure that your students are prepared, whether they are continuing at home distance learning or if they're beginning to start in-person learning in the classroom. Some of these things just to make it easier on you as the parent when these changes are taking place, and also these changes for students since it's been almost a year or over a year since students have been back in the buildings. So throughout this episode, we're going to be talking about some of these different things that you can do at home to make sure that your child is as ready and prepared as possible when they go back in the buildings or if they're continuing with distance learning at home. The resources that all students have, whether they're at home or they are inside the classroom, and they've been using this year as well, are some different resources through Clever. Now, in order for your child to sign in through Clever, they just have to sign in with their ID and their password, just as they would log on to their Chromebook or their email. Just as your students have been using possibly anything from Google Classroom this year or to anything else that your child's teacher has asked them to sign on to. So in Clever, there's a bunch of different resources that are paid for by the county. One of them is Dreambox. Hopefully, if your schools have them and have distributed all the passwords and IDs, your children have been getting onto Dreambox. Dreambox is something that helps your child with on-grade level math standards to make sure they're staying where they need to within their own grade level. It also is challenging, and it's kind of just fun in some games. There's some other different apps down here. We know our Big Ideas that connects to some different textbooks. We're not necessarily using that right now, but for the older students, that are those 6th, 7th, and 8th graders that have big ideas learning, they can use that. Now, to K through 5, they're in Envision, so don't worry too much about that. IXL, that's another site that your students can practice different math problems. It's connected to standards as well. And these are just some things that your students can do at home. Now, one of the main things that students have been using this year in K through 5 for their online resources and tools is Brainycam. Okay, and we're going to take a look at Brainycam just to show you some of the different online tools that your students can use when solving math problems. Brainycam is one of the apps that has been embedded into most of the activities that your students have been doing online this school year during distance learning. It's something that's going to be embedded in the activities and tasks that your students are doing the rest of the school year as well. Now, K through 2, we know that the majorities these are still going to be useful to them. And we know 3 through 5, some of the other ones such as algebra tiles, coordinate board. But these are all different resources for students to use. Now, one of the main things to build that fluency and understanding for students is using base 10 blocks. So we'll just take a look at it. We'll click on it. With the base 10 blocks, say students are adding a 3-digit number. Let's say the number is going to be 243 plus 325. We can put that text right there, and we know that that is something that they're adding. We literally can make 243 1, 2, 3, 4, and then here, if we wanted to do 325 down here, we can move these down. And the cool thing with this is really giving your students an opportunity to kind of just check their work, because down here at the bottom, it'll tell the total. Now, if they click that I, it'll take it away. But if they really want to just check to see if they did their work right, say they're doing their work in a notebook, or they're doing their work in Pear Deck. This is just an option for them to come and check their work to make sure that it is correct. So this is how, and there's a lot of different ways that they can use this. There's decimals, so those 4th and 5th graders with tenths and hundredths, they can use that as well. So this is one of those concrete models that really help support student understanding in terms of math. Now, back here, for the younger students, we have the tiles, there's Cuisinart rods, geo boards, hundreds board. There's just a lot of different things that students can use in order to help support their learning. So as a parent, check some of these out. Ask your students to show them, your child to show you how to utilize these so that you can get familiar with them as well. And if you have a little bit of time, you can log in through Clever with your student ID, your student's ID, and you can actually go through and check some of these out. So one of the organizational strategies that we've been working with students actually over the last couple years is the 3-read protocol. So it's important for you as a parent to understand how your child should be using this when they're solving math word problems. This is an organizational tool for students to kind of just get the problem started. So in a 3-read protocol, if you hear a teacher talking about this or your child mentioning this, this is how it's set up. So with a 3-read, the first read, students reading the problem. So what's going on in the actual problem? So they're just reading the problem as it is. The second read, what are the quantities? So what are the units? So they start pulling the units out of that particular problem. And then when they read the problem the third time, they actually come up with some math questions they can ask based on the information. Now, when teachers All right, so let's look at this example. It's titled Books, and we're doing that 3 read. So the first read, we're going to read through the information and break down. So at first, we have Miss Smith's class library has 423 books. 50 books were borrowed by students. Okay, so we know that this is math, and we're doing something. We're going to be either adding on or taking away. So we're reading through to understand the first 2 sentences. Notice there's no question yet. Second, we'll pull out the quantities and the units. The quantities are the numbers. The units are what's connected to those numbers. So the quantity, 423, the units are books. In the second sentence, 50 books, the 50 are the quantities and the books are the units. So third read, we'll read through it and we'll pick possibly a question that we could answer. Miss Smith's class library had 423 books. 50 books were borrowed by students. So a possible question could be, how many books are left if the 50 books are borrowed? So let's see what a possible question could be. How many books were left in the classroom library? So being able to come up with that question allows the students to realize what they might have to do when solving for the problem. Thank you guys for tuning in to another episode of Partnering with Parents. Today, we looked at some of those online resources that your child is using at home or in school. These are some different ways that they're learning how to do math on their computer. This is also some different ways that you can help support them going through some of those online tools, learning how to use the base 10 blocks or color tiles or the geoboards. Those are just some things that you can do. We know you don't have a lot of free time, but in your free time, your child can show you how to use some of these tools. We also went through a strategy that your child's using in their math classroom, which is the 3 read protocol. In these 3 read protocols, students are breaking down word problems. It's important for students to show their comprehension in terms of what the question's asking them, to grasp the understanding so that when they're solving it, they know exactly what they need to do when getting to that final answer. Thanks for tuning in for another episode. We look to see you guys in the future. Partnering with Parents episodes. I'm Coach Brenner. You guys have a great day.
4, 3, 2, 1.